Welcome to another episode of libGDX-Graph devlog. In this episode, I will show you how I created shaders required for this black hole and a star scene. I start off with this graph, very simple, where we have just the default pretty much setup here. So in here, I'll create a new shader for, this is called for star field. So the stars. So the way I want this setup, there is a sphere that is always centered on the position of the camera and is pretty large, and camera is always on the inside of the sphere. So when I edit it, so let's start off with, because I'm inside of the sphere, therefore I have to cool the front faces, because by default when you create a sphere in libGDX, the normals are pointing outwards, but because we are inside of the sphere, we have to switch the culling here. It's going to be opaque, everything else is going to be the same. Okay, so what I want to do here is basically have stars, but I want to always, whenever player looks in a specific direction, the star is going to be always the same. So I have to figure out which direction the camera is pointing at. So I'll start with a position attribute, which is position in the object, coordinate space, and I'll take the camera position here. And to get, basically what I want to do is basically the normal or the vector from the camera towards where the object is, but in the object space. So whenever it moves, camera moves, as I said, the sphere will follow the player because it's basically always in the same position as the camera. But I want to make sure that this is going to be the same, and I'll subtract those two. Subtracting these, and this is going to be vector, and I want to normalize it because I want to make sure it's going to be always the same regardless of the distance. So to normalize, it's going to be in geometric. So what these nodes are is basically a sky direction. So direction in which camera is pointing towards the sky, towards the star sphere. Okay, so what I'll use this for is to get a noise, simple noise 3D. I use this as a point, and I'll have here something that I use for the scale, because I have to make sure that it be able to figure out how many stars I want to be, how dense they have to be, and I have specified the range of the value at here. So if I now take here a math lerp, and I lerp the black and white colors. So black for the background and white for the stars. And they use this as a result here, as a color. You are seeing this gray because we have scale of 0. But we want to have, so this is going to be, the stars have to be much smaller. So let's try to figure out some kind of number that's going to be happy. Okay, these are, of course, we don't want this many of them. That's because we are seeing here everything from 0 to 1. So what I'll do here instead, then rather than directly pointing the simplex noise into the lerp, I will instead insert between those two step. So basically, if value of the noise, which is between 0 and 1, because that's how it's defined in the range, if it's greater than our edge, and I'll say 0.9 maybe, then the output of this step is going to be 1, which will result in having a white color. Otherwise, it's going to be black, so it's going to be much less of them. Okay, that looks like something I might use already. So let's try to see how it looks in our program here. So I have a program here set up that allows me to orbit and also rotate the camera. At the moment, so there is a object in the middle of this whole setup. That's why I can orbit here. You're not gonna see it, but I think this is pretty good sky here. So let's get back to the shader. And what I'll do here, I'll add a bloom effect. That's because I want the stars to have a, first of all, there's gonna be other objects that's gonna be very well lighted there. And also I want even though these stars are perfectly fine, I want the light to be much softer there. So I'll add a bloom post-processor here. As for the values, let's go with pretty big radius, maybe. Let's go with 10. Minimum brightness, let's say 0.8. And strength, let's go with something like 3. Okay, let's save it. Reload. Okay, and now we can see much brighter. You see the bloom around the stars. I think it's a bit too many stars. I'll increase the step here. Okay, and also what I don't like is that the stars are so close to each other, and well, mostly I'm worried about not really close to each other, but they are bigger. You can see some kind of clusters of stars or some much bigger star that you wouldn't normally see. So instead I'll just increase the scale of the noise, maybe 120. So let's see what impact it has. Yeah, the stars are much smaller. Now I'm still seeing a bit bigger here. So I'll maybe increase it even more to 150 maybe. So this defines how big the stars are. As you can see, if I do 10, the stars so-called are bigger, but let's go with 150. Okay, that looks pretty good for me. Okay, so we have now the star field done with just this small shader here. So let's now create a black hole. So in the center of this we have black hole. Because we want to be able to create a lensing effect on whatever was drawn before, we have to do it in a new render pass. So I'll create a new shader. Now we can create an empty or a load one, black hole. Okay, and let's edit it. So if I'll save it now, we can see that the black hole is in the center of this field and we are just orbiting around it, or we can rotate the camera away from it. So that's what I was saying about. So it's now at the moment drawn by default with a white color. So what we want to do instead is to, first of all, what I want to have is the center of this sphere, of this black hole, be completely black, and the edges, like some part of it, to be lensing. So let's start off with the Fresnel effect, which allows us to detect the edges on the spheres. So what we do here is normal attribute in world coordinates, and we want to have a difference between camera position and world position. And we want to subtract those two. So that's the view direction, because it's from, I disconnected it. The direction and the power, let's create a constant for now. Let's start with 1. Let's see how it ends up, if that's what we want. And let's call this setup a Fresnel. Okay. So output of this is this kind of sphere. So what we want to do now is cut off the center. So let's say we will say that if the value is bigger than, so we're gonna use this step. If the value here, input, is greater than constant cutoff point, so let's say 0.3, then this is gonna be 1. So let's do a lerp here based on this, and we'll start off with color black. For now, let's use color white for everything that is not cut off. So white here, otherwise it's gonna be black. So the center is gonna be black after I use this. Okay, and everything else is white. Okay, so this is the completely black center of the black hole. And what I need to do now is lens this part based on the entirety of what it's hiding. So let's say that point over here is going to be showing whatever was over here. So just a little bit off center. So we map whatever pixels are in this area to this area only. So to do that, I will take once again the value that I get from the Fresnel, and what I want to do is to read the scene color. So let's say this is black, so we don't want white. Instead of this, we'll have scene color here. Provided scene color. And I want to sample it. This is the change that I've done since the last episode, that this is the normal texture, just like properties or whatever. So I sample it, and I use color of that instead of the white. And as the UV, I'll be taking the so I want to move. So let's start off with model fragment coordinate. This is basically a coordinate of the center of the, where on the screen the center of this model is. So 0.0.0 coordinate in the object space where it's going to end up on the screen. And it's going to be in screen color. So let's say it's going to be 800 by 600. So this is going to be in this. So I want to multiply it by pixel size. This will give me the value between 0, 1, and in both directions, X and Y. So I want to multiply these two. So now I know where the center is, and I want to have the value of this be the screen position, which is a value of the actual pixel where it is on the screen in 0 to 1 range. And I will, so this is the center of the sphere, the black hole, and this is where on the screen the center is, and this is where the pixel is, and we want to lerp between those to mix it. And I'll use this as a UV here. And what we have here is we want to use the Fresnel for it. But the thing is that the Fresnel is from below 0.3 is cut off, so I'll have to remap the Fresnel. Value remap. So this is going to be input. And I want to remap it from 0.3, which is the value that we have here, which was the cutoff point. And I want to remap all of this into 0.1. So any value that is 0.3 will be value of 0 here, and anything above is going to be squeezed into this 0.1 area. Okay, I think that is what I want to do. So let's take a look at this. Okay, so we are seeing this effect here. I think I want to have it smaller, the inside of the sphere here be, so let's cut off at 0.2, and I have to change the mapping here as well. I could probably create this as a parameter here. Star field has a black color. I will use here a lighter color for now, just to be able to more easily see the black hole. Okay, and the effect it has. So we are seeing that the stars that enter behind this sphere of black hole are getting smudged because they are getting stretched and lensed around the black hole. Okay, that's a good point. I just change back the color of the star field to something a bit darker. Still not completely black. I want it to be completely black. Otherwise the black hole is not going to be very visible. Okay, so we have here. So what else is in this scene as well is the star that is orbiting this. Well, it's standing still, but I can orbit around the black hole and the star will get in front of the black hole and behind and so on. So the way this is done, because the star, depending where it is in relation to the black hole, it has to be rendered before, behind, or in front of the black hole. I have to have here two separate shaders for this. So let's start with the name of this I gave in the program is star surface behind. Okay, I save it, and now if I reload it, you can see here a star that is being nicely lensed. That's already pretty cool effect, I think. And of course, when it gets in front, it doesn't appear anymore because I switched the tag on the object there. So let's first do a better look at what I want to do with the star. So what I want to do is I want to lerp between two colors. Let's say it's going to be kind of brownish, like dark brown, and a bright yellow. Let's go with this kind of yellow here. And this is going to be a color. And for how we want this, I want to have noise, very simple 3D noise that is based on the position of the star in the object, because whenever it moves, I don't want this to change. And I'll specify here a scale. That's going to be how big. It's going to be like the star is not one color if you get closer to it. And I'll map this between, I want to have very little of the dark part and a lot of the light part. So I'll go with this, and even gonna be going into white because of the 2.0 here. So if we already put it here, it's not looking great. Okay, so this is gonna be how it's gonna be looking. Let's go to something smaller because the star in here is much bigger. Yeah, you're not really seeing the holes here. But however, I want to progress it. I want this to start to change. So let's introduce here a time. So the time has changed a bit. I integrated a multiplier here, so I don't have to do any additional multiplication node. I can do it directly here. I'll go with very small one because I want the changes to be done very slowly, as you can see here. So now reload it. Maybe I go with lighter, more yellowy, like a bit darker color here. Okay, we are seeing kind of this darker blotches, and they're going to be moving or changing because of the time there. So what I want to do now is I want to copy this shader. So what I do, I go to edit, I do a export shader, and here I specify where I want to save it. And then when I go here, I can create a new render pass. And in this render pass, I want to, from file, and the way I named this is star surface in front. I save it. So basically I took the same one here. It's just going to be drawn after the black hole. That means that whenever the star gets in front of the black hole, it's going to be drawn after the black hole. And you can see this blotches that are changing, like the darker spots on the sun, on the star. Okay, so one last thing I want to add to this is I want to add a corona. That's why you can see like the mass from the star is being going outside. So what I do here is I have set it up as the way it's set up is the actual star as actually two spheres, one encompassing the other. The behind the surface is the one that is underneath, and the one on top of it is the corona. So it's called star corona behind. And so let's save it and see how it looks. Okay, so now it's white only. So what we do want to do here is, first of all, it has to be transparent. That is because it's going to be drawn on top of the star underneath. I'll go for some nice yellow color for the star, and I will be modifying only the alpha value. So what we want for this to have is, first of all, the middle being empty. So once again, I'll produce the Fresnel effect here. Okay, so I have a Fresnel in here, and I'll once again use the technique I used before, which is use the step to cut off the inside. And I'll use this as the alpha. So let's go back to the application. And we are already seeing that the inside is unaffected and the outside is being drawn. But only if I go behind the sphere, here, behind the black hole. That's because I did not copy the shader yet, but I want to finish it first. Okay, so now what I want to do is create kind of rays here. And this is a bit more complicated. So the way I'll do this is to figure out take the position of the fragment. This is going to be in 0 to 1. Sorry, this is going to be, I'll take the position fragment, and this is going to be in width and height values. I'll split this into, because the fragment coordinates also has Z and W components. So I'll split this into X and Y, and I'll reconstitute them as vector 2. So this is going to be a fragment coordinate. (2D), and I'll subtract the fragment coordinate of the center of the sphere in this case, the model of the sphere in this case. So what this will give me, if I subtract these two, it is going to give me a direction. Well, I have to also normalize it. So let me quickly do math geometric normalize. So what this will give me is basically a unit vector from the center to the position on the sphere. So basically a direction. So for each of those pixels that is going to be in these that I'm pointing out here, the unit vector is going to be pointing up. So that way I'll be able to now use this to get noise value. Let's specify a scale here, as well as range. I'll pick up a bit larger range, and I will use this to multiply with the result of this cutoff point here that I used for the middle to be empty. Okay, we are already getting somewhere. So we have these arrays here, and we want to. The problem is that the arrays are uniform across the entire array. So what we want to do is have them fade out as they are further away from the center. So for that, I can use the Fresnel again, and I will do reverse the Fresnel, because if I just connect the Fresnel here, connect the Fresnel here, I'll get the opposite. The fully opaque is going to be on the outside, and it's going to fade out towards the middle. But that is not what we want. We want to do the opposite. So I'll have here a 1 minus. So 1 minus the Fresnel, and I can use this directly here. That's pretty good, but I want to have it fade out much more. So what I'll do here is use a power node. And use a power of 2 maybe. So this is going to change how much it's going to be fading out here. Okay, that's pretty good. Maybe a bit more. Maybe this. So we see the rays are fading out, but at the moment they are very stationary. And while it looks, I guess, okay here, I want them to be moving. And the way I would be moving is basically the same. The matter would be moving from the surface of the star to the edges. So in here I'll use a progress to have them moved, and I'll use a time, and I could just use it, but then as you can see they're not really moving from here to this. So what I will do here is I will, from the time, I'll subtract the result of the Fresnel. So I'll reuse the same node again. So what will happen is that because the Fresnel is value between 0.1 and when 1 is on the edges, the value that we see here is going to take 1 second to move out. I might maybe reduce the speed, and that way the matter looks like, I don't know, you have to look much closer on it to see that the matter is basically looks like it's moving outside. So the ray on here is changing before the size of the ray on the outside is moving. Okay, so let me copy this, export this shader once again, and I'll create here a new shader from file and load this file, and it's going to be called star corona in front. I'll save it and reload. And we have this beautiful matter flowing outside, and the lensing effect of the black hole. Okay, I hope you found this useful. Please consider subscribing and liking the video. Thanks for watching. Bye.